What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, for natural numbers a, b, and c, solve 1 plus 1 over a times 1 plus 1 over b times 1 plus 1 over c equal to 2. Well, since a, b, and c are natural numbers, that means a, b, and c cannot be equal to 0. But what if either of a, b, and c is equal to 1? Let's say a is equal to 1, for example. That means this first factor becomes 1 divided by 1, that's 1, plus 1, that's 2. So making this first factor to be 2. But since b and c are natural numbers, so the second factor and the third factor must be values that are greater than 1. So when 2 multiplies them, we're going to be having the left-hand side to be bigger than 2. And because of that, either of a, b, and c cannot be 1. Okay? What if a, b, and c are equal? So if a, b, and c are equal, so let's say b is also a and c is also a. And if they multiply, I'm going to be having the same expression, which is 1 plus 1 over a 3 times. And this is equal to 2. So let's get rid of the cube by taking the cube roots of both sides. So the cube root of the left and also the cube root of the right. So the cube root can cancel off the cube, leaving behind 1 plus 1 over a to be equal to the cube root of 2. And since I'm looking for a, my next step will be for me to move 1 to the right hand side so that I have 1 over a to be equal to the cube root of 2. And as 1 crosses to the right, it becomes minus 1. And since I'm looking for a, in order to get a, I'm going to be taking the inverse of both sides. So the inverse of 1 over a is a. This is equal to the inverse of 1 over the cube root of 2 minus 1 is 1 all over the cube root of 2 minus 1. And since a is a natural number, this value here is not a natural number. So that means this is rejected. So a, b, and c cannot be equal. Now, let's say it this way. If you look at the expression on the left, you notice that it is symmetric. That means if I swap the positions of a, b, and c, or between a and b, or between a and c, or between b and c, the expression on the left will still be the same. And because of that, I'll say without loss of generality, which is one log, let's assume a as the smallest, followed by b, and then take c to be the largest. So coming to this expression, we know that the smaller the denominator, the bigger the factor. That means this first factor is bigger than the second factor, and the second factor is bigger than the third factor. So that means the expression on the left is decreasing. And for that, let's establish a bound on the smallest number a, such that when a exceeds that number, then it is impossible for the left-hand side to be equal to 2. And in order to do that, I'm going to be writing 1 over b and 1 over c in terms of 1 over a. So this expression becomes 1 plus 1 over a times 1 plus 1 over a. Remember, I'm writing 1 over b in terms of 1 over a. I'll do the same thing here, times 1 plus 1 over a. And this expression is bigger than the original expression, which is 1 plus 1 over A times 1 plus 1 over B times 1 plus 1 over C. Now notice that the left-hand side, we have 1 plus 1 over A repeated 3 times. So this can be written as 1 plus 1 over A raised to the power of 3. And this is bigger than the original expression from the question is equal to 2. So I'm going to be writing 2 here. Cool. Our next step will be for us to remove this power of 3 by taking the cube roots of both sides. So I'm going to be taking the cube root of the left-hand side, and I'll also take the cube root of the right-hand side. So the cube root cancels off the cube, so that we have 1 plus 1 over A to be bigger than the cube root of 2. Our next step will be for us to move 1 to the right-hand side, so that I have 1 over A to be bigger than the cube root of 2. And as 1 crosses to the right, it becomes negative 1. And since I'm looking for A, that means our next step will be for us to take the inverse of both sides. So the inverse of 1 over A is A, and taking the inverse of both sides changes this equality sign to the opposite direction. So the inverse of cube root of 2 minus 1 gives 1 all over the cube root of 2 minus 1. So this expression can be simplified into 1 all over the cube root of 2 is 1.25 minus 1. That means this is 1 all over 1.25 minus 1 is 0.25. And 1 divided by 0.25 is something close to, let's say, 3.85 or something like that. So A is lesser than 3.8. And since A is a natural number, that means A is not up to 4. And from what we have seen, that A is not also equal to 1. So A can either be 2 or 3. So we're going to be solving this one after the other. We solve for when A is equal to 2 to find the value of B and C. And we also solve for when A is equal to 3 to find the corresponding values of B and C as well. Let's do that in the next slide. So when A is equal to 2, that means this becomes 1 plus 1 over A is 2 times 1 plus 1 over B times 1 plus 1 over C equal to 2. So this first factor simplifies into 2 times 1, that's 2, plus 1, that's 3. So this is 3 over 2 times 1 plus 1 over B times 1 plus 1 over C is equal to 2. Our next step will be for us to divide both sides by 3 over 2. So I'll divide the left-hand side by 3 over 2. I'll also divide the right-hand side by 3 over 2. So 3 over 2 cancels off 3 over 2, leaving behind 1 plus 1 over B times 1 plus 1 over C to be equal to, now 2 times 2 is 4, so this is 4 over 3. Our next step will be for us to open up the bracket. So 1 times 1 is 1 plus 1 times 1 over C is 1 over C. Now 1 over B times 1 is 1 over B plus 1 over B times 1 over C is 1 all over BC. and this is equal to 4 over 3. Our next step will be for us to clear the fractions, and in order to do that, I'm going to be multiplying through by the LCM. So the LCM of C, B, BC, and 3 is 3BC. So let's multiply through by 3BC. So 3BC times 1 is 3BC plus 3BC times 1 over C is 3B plus 3BC times 1 over B is 3C plus 3BC times 1 over BC is 3 equal to 3BC times 4 over 3 is 4BC. Our next step is to move everything to one side. I'm going to be moving what is on the left hand side to the right hand side. So I've already got 4BC, so 4BC. When I move 3BC to the right, it becomes minus 3BC. When I move 3B to the right, it becomes minus 3B. When I move 3C to the right, it becomes minus 3C. And when I move 3 to the right, it becomes minus 3. And this is equal to 0. Simplifying further, 4BC minus 3BC is BC. Minus 3BC, minus 3B rather, minus 3C, minus 3 equal to 0. Now let's factorize. You notice that B is common, so we can factor out B. So BC divided by B, I have C, minus 3B divided by B, I have 3. And also, you notice that negative 3 is common from here, so we can factor out negative 3. So negative 3C divided by negative 3, I have C. And since I want what is inside of this bracket to be the same as what I have here, I'll be putting minus 3 here. But if you notice, when I multiply negative 3 times negative 3, I'll have 9. But what I have here is not 9. This is negative 3. So what can I do to make this to be 9? I'm going to be adding 12 to it. So when I add 12 to negative 3, it will make this expression here 9. But I can't just do that only on the left hand side. I will also be doing that on the right hand side. So I'll be adding 12 on the right hand side to balance that up. So this is equal to 12. So this simplifies into two factors. We have B minus 3 times C minus 3 equal to 12. Let's continue on the next slide. So we have two factors multiplying to give 12. But recall that B is smaller than C. So our next step will be for us to write all the factors of 12. So we have B minus 3 times C minus 3. So this is equal to, since B is smaller, so it will be taking the smaller factor of 12. So this is 1 times 12. Another factor of 12 is we have 2 times 6. And we have the last one, 3 times 4. That's it. So we're going to be pairing the smaller factor to B minus 3. I'll be pairing the bigger factor to C minus 3. So that means B minus 3 is equal to 1, while C minus 3 is equal to the bigger factor 12. So solving this, I'm going to be moving negative 3 to the right hand side, making it plus 3. So 1 plus 3 is 4. So this makes the value of B to be 4. While for here, I'm going to be moving negative 3 to the right, making it plus 3. So 12 plus 3 is 15. So C is equal to 15. So the values of A, B, and C from this is equal to, Remember, we are solving for when A is 2, and B is 4, C is 15. Now let's go again. For the other factor, we have B minus 3 to be equal to the smaller factor, which is 2, and C minus 3 to be equal to the bigger factor, which is 6. So solving this, I'll be having B to be equal to, when I move negative 3 to the right, becomes plus 3. So 2 plus 3 is 5. The same thing here, when I move negative 3 to the right, becomes plus 3. So 6 plus 3 is 9, making C to be equal to 9. So the values of A, B, and C here is equal to, remember, we are solving for when A is 2, B will be 5, and C will be 9. All right, now let's go to the last factor. This time, B minus 3, which is a smaller factor, is equal to 3. And C minus 3, which is the bigger factor, is equal to 4. So this makes B to be equal to negative 3 to the right becomes plus 3. So 3 plus 3 is 6. C will be equal to negative 3 to the right is plus 3. So 4 plus 3 is 7. So the value of A, B, and C here, A is 2. Remember, we're solving for when A is 2. B is 6. And C is 7. Now let's solve for when A is equal to 3. Let's do that on the next slide. So we are doing when A is equal to 3. So this expression becomes 1 plus 1 over 3 times 1 plus 1 over B times 1 plus 1 over C. And this is equal to 2. So simplifying this inside of this bracket, we have 3 times 1, that's 3, plus 1 is 4. So this is 4 over 3 times 1 plus 1 over B times 1 plus 1 over C, and this is equal to 2. Our next step will be for us to divide both sides by 4 over 3. So I'll divide the left-hand side by 4 over 3. I'll also divide the right-hand side by 4 over 3. So 4 over 3 cancels 4 over 3, leaving behind 1 plus 1 plus 1 over B times 1 plus 1 over C to be equal to, now 2 times 3 is 6, which is 6 over 4, which can be broken down into 6 divided by 2 is 3, 4 divided by 2 is 2. So this is broken down into 3 over 2. Our next step will be for us to open up this bracket. So 1 times 1 is 1, plus 1 times 1 over C is 1 over C, plus 1 over B times 1 is 1 over B, plus 1 over B times 1 over C is 1 all over BC. And this is equal to 3 over 2. Our next step will be for us to clear the fractions, and we do that by multiplying through by the LCM. And the LCM of C, B, BC, and 2 is 2BC. So let's multiply through by 2BC. So 2BC times 1 is 2BC, plus 2BC times 1 over C is 2B, plus 2BC times 1 over B is 2C, plus 2BC times 1 over BC is 2, equal to 2BC times 3 over 2 is 3BC. Our next step will be for us to move all the expressions on the left to the right. So I've already got 3BC on the right. So when 2BC crosses over, it becomes minus 2BC. When 2b crosses, it becomes minus 2b. This becomes minus 2c, and this becomes minus 2, equal to 0. Now simplifying further, 3bc minus 2bc is bc. This is minus 2b, this is minus 2c, and this is minus 2, equal to 0. And our next step will be for us to factorize. Notice that b is common, so let's factor out b. So bc divided by b is c, minus 2b divided by b is what? 2. So this is minus 2. What's common here? I have negative 2 common, so bring it out. So negative 2c divided by negative 2, I have c. And since I want what is inside of this bracket to be the same as the one here, let me write minus 2 here. You see that? So what is inside of this bracket are the same. But in order to make this possible, let's multiply this negative 2 times negative 2. So negative 2 times negative 2 gives 4. So what am I going to add to negative 2 to make it 4? 6 is the value, right? So I'm going to be adding 6 to the left-hand side in order to make this valid. And whatever I do to the left, I will do to the right. So plus 6. I also add 6 to the right. So this is equal to 6. So this factor into b minus 2 times c minus 2 to be equal to 6. Let's continue on the next slide. So we see that 2 factors on the left multiply to give 6. But recall that b is smaller than c. So our next step will be for us to write the factors of 6. So this becomes b minus 2 times c minus 2. So the factors of 6 are, we're going to be giving the smaller factor to b. So we have 1 times 6, and we have 2 times 3. So that means b minus 2 will be equal to the smaller factor 1, and c minus 2 will be equal to the bigger factor 6. So to get b, we're going to be moving negative 2 to the right hand side to become plus 2. So 1 plus 2 is 3. And to get c, I'm going to be moving negative 2 to the right to become plus 2. So 6 plus 2 is 8. So the values of a, b, and c are, remember, we are solving for when a is 3, b is 3, while c is 8. Now let's go to the second factor. So b minus 2 will be given to the smaller factor 2, while c minus 2 will be given to the bigger factor 3. So that b becomes negative 2 crosses to the right, becomes plus 2. So 2 plus 2 is 4. And c becomes, as negative 2 crosses to the right, becomes plus 2. So 3 plus 2 is 5. So the values of a, b, and c here will be equal to, we're solving for when a is 3. So b, we got the value to be 4, and c is 5. Remember that the original expression from the question is symmetric. So the values of a, b, and c can be interchangeable depending on which one you choose to be the smallest. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.